So today the topic of our video will be linear homogeneous PDE with constant coefficients. Actually, we are continuing that this topic from our last video. And what we did in our last video, we wrote this result, a particular solution, 1 upon f d d dash, and here we had phi ax plus by, and we discussed for the case when this FAB was 0, and precisely it was of the form B D minus A D dash whole to the power n, right? And the result was x to the power n phi ax plus by upon n factorial multiplied by b to the power n for the case if f a comma b is equal to 0. So this was the formula we derived in our last video. So when the denominator goes to 0, by substituting d is equal to small a and d dash equal to small b, and then we use this result. We have done its proof. In this video we will be discussing problems based on this formula, right? So example number 1, solve d square plus 2d d dash plus d dash square z is equal to sine of x plus y, right? Solution, its factors will be d plus d dash whole square, it is whole square z equal to 0. Take let, right? And writing it complementary function, that will be since factors are repeated, then the complementary function will be f1 y plus x, the sign gets reversed, minus x. Okay, I think it should be minus here, then minus, then plus. Okay, right. Okay. Plus x times f2 y plus x. This is the complementary function where f1 and f2 are arbitrary functions. Okay, and particular solution is equal to 1 upon this d minus d dash whole square, and here we have sine x plus y. Now sine x plus y is of the form phi of ax plus by, where a is equal to 1 and b is equal to 1, right? And as we discussed in our last videos, that we substitute d is equal to a and d dash equal to 1, but this time I will get 0 in the denominator on substituting d is equal to 1 and d dash equal to 1. So I have to use this formula, right? This is the formula which shall be used for the case when the denominator goes to 0, right? So I am using this result directly, and since x to the power n, where n is the order of this power of this linear factor, right? And what is that? N, that is 2. Then it will become x square sine x plus y upon, here we have n factorial means 2 factorial, and b to the power n. What is b? B is actually the coefficient of capital D, and the coefficient of capital D is equal to 1 here. So 1 to the power 2, right? 1 to the power 2. I will mention, I use this result, right? Here using this formula for n is equal to 2 and b is equal to 1. Okay, so this is the answer. 2 factorial is 2. That's it, right? So the complete solution will be z is equal to cf plus pi is complete solution, right? Now taking another example, example number 2, right? Let me take a d minus 2d dash and d minus d dash, then it will become d square plus 3d d dash plus 2d dash square, right? Okay, and z equal to should I take it as minus sign, d minus 2d dash d, okay, and the factors will be d minus 2d dash and d minus d dash, and let me take here e to the power x plus y, okay, right. Then solution will be let d square minus 3d d dash plus 2d dash square z equal to 0. So considering 0 for the right hand side to find the complementary function and factorizing it, are d minus 2d dash and d minus d dash z equal to 0. Am I correct? 2d square, right? Fine. Okay. Then writing the complementary function, as you know it well, how to write a complementary function from these linear factors. Then I think f1y plus 2x, note that the sign gets reversed, and f2, because factors are distinct, so f1 f2, and y plus x is the complementary function, and f1 and f2 are arbitrary functions. Okay, then particular solution equal to 1 upon writing in factorized form d minus 2d dash and d minus d dash. Let me write d minus d dash here and d minus 2d dash and then e to the power x plus y. I have written this factor here because this is the factor we are concerned with, because it goes to 0. If I put d equal to 1 and d dash equal to 1, then it will go to 0. So I have written that factor here because commutative property can always be applied in these factors term, right? Okay, then operating this first, right? But please pay attention here that putting d equal to 1 and d dash equal to 1 will give something, I think minus 1, and that is not equal to 0. So for this case, to apply this operator 1 upon d minus d 2d dash on this function e to the power x plus y, this formula will not be used. We will use the previous formula as we discussed in our last videos, and that formula was very easy: 1 upon d minus d dash, and then d is equal to 1 and d dash is also equal to 1. D is replaced by a small a. Small a is the coefficient of x, and d dash is replaced by small b. Small b is coefficient of y. They both are 1 here, right? And this gets integrated e to the power u du, where what is u? U is equal to ax plus by. Please refer to our last videos to understand how this comes, right? This portion. Okay. And why I have integrated only once? Because see, the power d to the power 1 means 1 degree in sense of a polynomial, right? Okay. Then it will become minus, okay, and integration will be e to the power u. Ultimately, I will be getting 1 upon d minus d dash, and here I will have minus of eu. Let me put this minus here, okay, right? After integration and substituting back u is equal to x plus y, I will get to the power x plus y. So I reach here, okay. Now here comes into play this formula. If you put d is equal to 1 and d dash equal to 1, you will get 0 in the denominator, and that's why we'll be using this formula this time. And see what is b. B is actually the coefficient of d. Using this formula, I need b, and b is coefficient of d, and that is 1, right? And what is n here? N is 1, right? So the answer will be minus x times u to the power x plus y. N factorial means 1 factorial, b to the power 1, b to the power n, and I think this will be minus of x e to the power x plus y, right? Minus x e to the power x plus y. Here n is equal to 1 and b is equal to 1 for that formula, right? And the solution will be z equal to cf plus pi. Cf plus pi is solution, right? So Taking another example, example number 3. Let me take d square, and here I had x plus y. So if I take minus 5d dash plus 4d dash square, z is equal to, the factors will be d minus 4d dash, and that will be plus 4x y plus 4x and square root of y plus 4x, right? Okay, then solution will be, should I write the complementary function directly, or let me factorize this first? D minus 4d dash and d minus d dash z equal to 0. Yes, right. Okay. Then complementary function will be written as f1 y plus 4x and f2 y plus x is the complementary function. You can write it easily, where f1 and f2 are arbitrary functions, right? Now finding a particular solution, that will be 1 upon writing d minus 4d dash first and then d minus d dash later, and then here we have under root of y plus 4x, correct, right? Now operating this 1 upon d minus d dash first on this, and notice that if I put d is equal to the coefficient of x, that is 4, and d dash equal to coefficient of y, that is 1, I will get something a non-zero value, right? So I have to use the previous formula, that is 1 upon d minus 4d dash, and that will be integrated once. I will write it to u to the power half du, where u is actually y plus 4x, right? And why I have integrated once? Because this factor is a first order operator, right? In that sense. Okay, then integrating it will give u to the power 3 by 2 and 2 by 3, then 2 by 3 will appear here, 1 upon d minus 4d dash, u to the power 3 by 2, that is y plus 4x to the power 3 by 2 after integrating it, right? Okay, then now see that this time if you put d is equal to 4 and d dash equal to 1, you will get 0 in the denominator. So again this formula comes into play, right? And then according to this formula, 2 by 3 in the numerator I have to put x, y plus 4x to the power 3 by 2, and in the denominator I will have, I think, 1 factorial, because 1 is the power of this n equal to 1 comparing with this formula, and coefficient of d is also 1, so this will be the answer, right? Here n equal to 1 and b is also equal to 1, so ultimately the answer will be 2 by 3 x y plus 4x to the power 3 by 2. And now you can write the complete solution, z equal to cf plus pi, right? So we have discussed the case when the denominator goes to 0, in case when the right hand side is phi of ax plus by, and the examples are sufficient, right? So we will take another small topic here. Let me rub it first. So let me discuss the general method which works for all kind of the function that was our gxy present on the right hand side of our linear differential equation with constant coefficient, and with that general method you will be able to find the particular solution in all cases, right, irrespective of the nature of the function present on the right hand side. Or you can say that irrespective of the case when the denominator goes to 0 or non-zero quantity, you can use this method freely, because this is the most general method, right? Okay, and the method is, I'm writing the general method, right? General method to find particular solution, PS, right? And it works for all cases, right? Okay, and that the method is particular solution 1 upon f of d comma d dash, right? And right hand side is anything. It may be suppose I write it as We have written capital Gxy in our equation. Let capital G x comma y. Please refer to our equation number A in our last videos, right? Gxy is the right hand side of our PDE, okay? That may be any function, okay? Then the method says that no, the FDD dash should be present in this linear factor form, okay, right? Now it is correct. D minus MD dash, because we know that the FDD dash operator can always be expressed as a product of linear factors. So I have written only one factor here, okay. So for one linear factor and with the right hand side is Gxy, the particular solution is given by this formula. Notice this formula, integral G x comma C minus mx dx. This is the formula. Right? It just replaces y by c minus mx, right? And integrated once because one linear factor was there, right? And those who love integration, this formula is quite handy because it only involves integration, right? Okay, let me give a small proof of this formula, right? And for that I have to write, consider d minus md dash z is equal to the right hand side capital G x comma y. And why I have taken this particular PDE, you know, all know that, because writing here z and then cross multiplying it, I will get this PDE, okay. And obviously it is a Lagrange's form PDE, or I can write it as then d operated on z will give a small p. Remember that del z over del x is a small p, and d dash operated on z will give a small q. Del z over del y is small q, standard notation. And right hand side is capital G x comma y. So this is my Lagrange's form equation. Okay. Then Lagrange's subsidiary equation are given by dx upon the coefficient of small p, that is 1, dy upon the coefficient of small q, that is minus m, and dz upon this right hand side term g x comma y. These are called Lagrange's subsidiary equation. Please refer to our last videos to understand what this method was, right? Okay, now taking these two ratios, taking dx upon 1 equal to dy upon minus m and cross multiplying and applying integration on both sides, then I will get gives y plus mx equal to c1, where c1 is the constant of integration, right? And then taking the first and the third ratio, dx upon 1 equal to dz upon g x comma y, taking the first and the last ratio. Now I want to integrate it, but unfortunately I can integrate this, yes, but dz, below dz we have this combined function, means function of x and y, composite function of x and y, right? So what should I do? I should replace this y from this value, or y is equal to c1 minus mx. I don't need y here, I need x and z to integrate it. Gives g x comma c1 minus mx. Let me write it c, no need to write c1, okay, c minus mx dx equal to dz, okay. This will be obtained, and then putting integration on both sides. If I apply integration on both sides, then integration of dz will be z, and integration of this will be g x c minus mx dx, and this will be our z. And do not write, please do not write plus c, another constant, because we are focusing on particular solution. Particular solution do not contain any constant, right? However, it appears that a constant is involved in this equation, but this constant will be again replaced by c is equal to y plus mx, means after integrating it, right, and we will be having C in our answer, then C will be replaced by y plus mx. Then we'll get a constant free particular solution, because we are finding particular solution, and that is always a constant free, right? And that's why I don't write here plus C2, because that will cause me trouble to remove that C2. Okay, or you can say that I have chosen C2 equal to 0. And the value of z, what is z? Z is actually 1 upon this thing, or 1 upon d minus md dash and g of xy equal to integration g x c minus mx dx. So you can see that this result is indeed the same as we wanted to prove. See this, right? So in numericals we will go with this. Okay, taking a numerical of it. First example number 1, based on this general method, d square plus d dash minus 6d dash square and z equal to y cos x, right? Okay, and see here, right hand side is a function g x comma y, and this kind of function has not been treated yet in any of our last videos, right? We talked about phi of ax plus by, right? And we talked about x to the power m and y to the power m, but we never talked about this kind of this product function y multiplied by cos x, right? So this is a general method, and it works for all kind of functions, right? Provided you can integrate it. Okay, then solution. Let me factorize it first. D, I need minus here and plus here. D plus 3d dash and d minus 2d dash z equal to 0. Oh, okay, correct, right? Now writing its complementary function, then CF is equal to f1 y minus 3x, f2 y plus 2x. This sign gets changed. This is a complementary function where f1 and f2 are arbitrary functions, right? And particular solution 1 upon this factorized form of ftd dash. Okay, and here we have y cos x. Okay, so now we will apply this formula directly. Okay, now compare this formula with this, and notice that this formula works for only one linear factor once. Okay, so here we have to apply this formula twice, first for this factor, then the second time for this factor. Okay, so d minus d dash 1 upon 2 minus d minus 2d dash operated on y cos x means for this part I will apply this formula. Okay, it will give 1 upon d plus 3d dash and integration, and y is replaced by c minus 2x and cos x and dx, and I have to mention what is my c minus 2x. Y is equal to c minus 2x, right? You can think in that way, that y takes c minus 2x, d replaced by small c and d dash replaced by small x. You can think like that. Okay, now integration. Okay, now two functions. Okay, first an algebraic function, trigonometric function, Eilert rule, or you can use a shortcut method for Eilert, and I think you know that method. That will be first function as it is, and integration of second function, that will be I think sin x, and then we change the sign, and then differentiation of this bracket, that will be minus 2, and then integration of this bracket, that will be minus cos x. Okay, then we are done. Okay, right, one line integration formula. Okay, I think you know this formula, or should I mention this note what I used? I use this integration of u, v, dx, two functions u and v, right? And selecting them according to the Eilert principle, means algebraic should be taken as u and trigonometric should be taken as v. Then the formula is u and v1 minus u dash v2 plus u double dash v3, and then minus and so on. This is the formula. u is the first function. v1 is actually the integration of v one times and then minus sign, then u dash is the differentiation of this u, and v2 is the again integration of this will be v2 and then sign change, and then u dash again differentiation of this bracket will be u double dash, and v2 integration of v2 will be v3. But please be careful while using this result, because a bracket should be maintained. If you open any bracket in any of these steps, then this formula will go wrong, right? So please maintain brackets as I have maintained. Minus sign should be written inside bracket, that's okay, c minus 2x, and c here minus 2. Do not take this minus outside, otherwise you will be applying this formula in a wrong way, right? Okay, then this will give me 1 upon d plus 3d dash, and then c minus 2x. And what is my c minus 2x? That is my y, because I told here that after integration the value of c should be substituted back here, right, to get a constant VPS. Okay, then putting the value of c back from here, I will get y sin x. Okay, then y sin x, and this will become, I think, minus 2 cos x, right, where I have substituted the value of c. Okay, no need to write it again. Okay, now here comes another factor, d plus 3d dash, and again you have to apply this formula, but this time y will be replaced by c plus 3x, and integrating 1, c plus 3x sin x minus 2 cos x, right, and dx, and y is replaced by c plus 3x. We have to mention it, y is equal to c plus 3x, right? You can use another constant k plus 3x, because c have been used, but that is immaterial, because c has again been replaced by y. Okay, that's it. You can use again c. Okay, c plus 3. That's now integrate it. The integration again using that one line integration formula. Okay, c plus 3x is my u and v is my sin x. So u inside first bracket, and then integration of v, that is minus cos x, but please do not write this minus sign outside. Let it be here inside bracket. Then minus, then differentiation of this bracket will be 3, and integration of this bracket will be minus sin x, and do not try to take any sign out of the bracket. Okay, now we are done for this. Okay, that's it, because here I have constant, and for the another term I will be differentiating this constant, and that will give me 0. That's why the formula terminates here. Okay, then for minus 2 cos x, the integration will be minus 2 sin x, and let me simplify it. C plus 3x will be back substituted by y. I will have minus y cos x, minus y cos x for this term, that will be plus 3 sin x minus 2 sin x, so plus sin x. So this is the particular solution, and see, it is a constant free, right? And complete solution will be given by sum of CF plus PI. Now, taking another example, let me rub this hole. Okay. Let me change the right hand side, e to the power x plus 2y, the exponential function multiplied with some function. Okay, and the left hand side can be taken same, or you can change it, d square minus dd dash minus 2d dash square. Okay, so we are concerned with the right hand side only. Okay, see the difference between these two. It was a y multiplied by a trigonometric function, and this time we have exponential function multiplied by x plus 2y. Okay, so we are having combined forms on the right hand side. Okay, so first we will factorize it, right, and let me factorize it. We'll get d, that will minus 2d dash and d plus d dash, right, okay, and z equal to 0. Then CF will be f1 y plus 2x, f2 y minus x is the complementary function. F1 and f2 are arbitrary functions, correct. And particular solution, the factors are written in product of linear factors only, and here I have e to x plus 2y, right. So we'll be going to operate 1 upon d plus d dash for first, and since you know that this is a commutative, choose any of these factors, whichever you prefer. You can write d plus d dash here and d minus 2d dash here, and that is immaterial. The result will be same. Okay, so focusing on this factor, and 1 upon d minus 2d dash will be waiting outside the integration. Okay, now e to the power x, and see this x plus 2 times the y will be replaced by c plus x, c plus x, and here we have dx, and I have to mention y is replaced by c plus x. Okay, now should I simplify it first? It will be, I think, 2c plus 3x, yes, and then e to the power x dx. Okay, remember that this is u, this is v, right? Because exponential function is always taken as the second function inside integration according to the Eilert rule, and then applying again that shortcut formula, I will have u inside bracket and integration of v inside bracket, then minus differentiation of this bracket in term with respect to x 3, and integration of this bracket, that will be again e to the power x, then sign change plus, then differentiation of this will be 0, so the formula stops here, right? Okay, that's it. And again simplifying it will give d minus 2d dash, and I think e to the power x will be taken common, and inside I will have 2c plus 3x minus 3, 2c plus 3x minus 3, and outside I will have e to the power x. But what about c? C should be replaced back. What is c? C is y minus x. Substitute y minus x here, and I will get 2y minus 2x, and then 2y plus x. 2y plus x after simplification on substituting back the value of c. Okay, that is fine. Okay, correct. Now what should I do? 2c plus 3x minus 3, let's get 2c plus 3x, 2c, 2y plus 2x, 2y plus 2x plus 3x minus 3. I think it should be 5x, no? No, 2c, c is equal to y minus x. No, it is correct, fine. Okay. Now applying this operator, integration, this time y will be replaced by 2 times of c minus 2x plus x minus 3, and then multiplied with e to the power x dx, where y is equal to c minus 2x, right? Okay, then simplification, it will give 2c minus 3x minus 3 and e to the power x dx, and then applying the integration formula, I will have 2c minus 3x minus 3, e to the power x integration will be e to the power x minus differentiation of this thing will be minus 3 and e to the power x, then done. Okay, then putting the back the value of c, I will get to y, c is equal to y plus 2x, so it will be 2y plus 2x, then minus x, then minus 3, and then that will be plus 3, and that will be cancelled. So ultimately I will be having this e to the power x. This is a particular solution, and then CA plus PI will give the complete solution. Okay, so we'll take another example. I'll change this right hand side. Okay, and erase this. Two cos y minus x sin y, changing the right hand side. Okay, and that's fine, right? Okay, should I change the left hand side also? That will be, let me change it here, perfect square form, 2d d dash, 2d d dash plus d dash square, in order to get a square. Since the last example we are getting distinct factors, and this time I will be getting repeated factors. Okay, that's fine. Okay, so let d square plus 2d d should I factorize it first? Okay, no problem. D plus D dash and D plus D dash Z equal to 0, factorizing it and getting linear repeated factors. Okay, and then CF will be for repeated factors, it will be f1 y minus x plus x times f2 y minus x. This is the complementary function. Okay, and particular solution 1 upon d plus d dash, because it is this time it is a square, and the other writing that is square, write in terms of linear factors, because you have to apply one factor once, one operator once. Okay, and here we have a long function 2 cos y minus x sin y. It is a long function as compared to our previous examples, actually the combination of two different functions. Now what should I do? Okay, operating this first, 1 upon d plus d dash will wait outside, and then integration 2 cos y is replaced by c plus x minus x sine c plus x. Okay, am I right? Yes. Okay, and dx, and where y is equal to c plus x. Okay, right. Then integration of this thing will be 1 upon d plus d dash, waiting for this term, and integration of 2 cos x will be 2 sine c plus x. Okay, and for that I have to apply again that by parts rule, shortcut formula, and I'm using that formula. Taking first function will be x. Okay, that's fine. First function I will put a bracket here, first function x, and integration of second will be minus cos c plus x, bracket. Okay, and then sign reversed, sign change, x differential will be 1, integration of this will be sine of, no, minus sine c plus x. Done. Okay, done. Right, and then solving it, I think 2 sine c plus x, and this is plus minus, ultimately it will be sine c plus x on simplification. Yes. Okay, and that will be plus x cos c plus x, and then getting rid of this c. How to get rid of this c? Replace y here. Okay, that will become 1 upon d plus d dash sine y plus x cos y. Now it is constant free. Okay, and as soon as it becomes constant free, then you start applying this operator. Okay, do not apply this operator in this position, right? Okay, then again the same thing, integration of sine c plus x plus, again because the factor is repeated, x cos c plus x dx, where y is equal to c plus x again this time. Okay, now apply integration. I have to put a bracket here. Integration of sine is minus cos c plus x for this term, and for this term again that rule, long rule, x integration of cos is sine c plus x minus 1 integration of sine is minus cos c plus x. That's it. Okay, right. Now substituting back the value of c plus x. Okay, I will be getting, I think this is minus cos and this is plus cos, that those terms will be cancelled. Okay, I am getting sine x sine y, x sine y. This is my answer, right? And you can verify that the particular solution definitely satisfies this equation. If you substitute, plug in this z is equal to z, take z is equal to x sine y here, and apply this operator on z, you will get 2 cos y minus x sine y in order to check your calculation. Okay, and the complete solution then will be written as CF plus PS, right? And that's it for this video, and we'll do another topic in our next video. So thank you so much for this video. Thank you.